Good morning. We are going to study about electromagnetic induction. Electromagnetic induction means the process by which an EMF and hence current is generated or induced in a conductor when there is a change in magnetic flux or linking the conductor is called electromagnetic induction. That means just with an example I will explain what is. Just assume a coil or a conductor. Okay, just assume a coil is there and near to that a magnet is here. Okay, a north pole and south pole magnet is placed here. Okay, when we vary when we move this magnet near and away or in a horizontal way, in a vertical manner or in a horizontal manner, just we move the magnet from the coil far away and to near to the magnet. What happened? The magnetic field lines linked with the coil will vary. That means we are changing the magnetic field linked with that coil by moving the magnet. Or either we can move the coil. There are two methods. That means if we move the magnet or if we move the coil, we can change the magnetic field. Okay, when we move the coil either in direction, then also we can produce a change in magnetic field. So when we place a coil, in another way we can also when just assume a magnet and we are wounding a coil on this magnet. Okay, then when we move this magnet inside the coil in horizontal left to right, what happened? Then also the magnetic field lines will cut with the coil. Okay, അതായത് നമ്മൾ ഒരു മാഗ്നറ്റും ഒരു കോയിലും പ്ലേസ് ചെയ്തിരിക്കുകയാണ്. ഒരു കോയിലിനകത്ത് വെച്ചിരിക്കുന്ന മാഗ്നറ്റ് അല്ലെങ്കിൽ കോയിലിന് പുറത്ത് വെച്ചിരിക്കുന്ന മാഗ്നറ്റ് നിയർ ആൻഡ് എവേ ആയിട്ട് മൂവ് ചെയ്യുവാണെങ്കിൽ the magnetic flux lines linked with that coil will changes. Magnetic flux lines change ചെയ്യുമ്പോൾ എന്താ സംഭവിക്കുക? They will produce an EMF inside that conductor. Okay, so once again I will explain. So the process by which an EMF and hence current is generated or induced in a conductor when there is a change in magnetic flux linking with the conductor is called electromagnetic induction. That means when a coil, we also already told, if the coil is a closed path, that coil is a closed path, when we place a magnet inside that, the change in magnetic field due to the movement of magnet will produce a electromotive force or voltage in the EMF in the coil. That we know that the coil is a closed circuit, so it will produce a current. That means the process by which an EMF and hence current is generated is called is induced, generated or induced in a conductor is electromagnetic induction. That means when there is a change in magnetic flux, then only it will produce an EMF inside the conductor. ഒരു ചേഞ്ച് ഇൻ മാഗ്നറ്റിക് ഫീൽഡ് ഉണ്ടെങ്കിൽ മാത്രമേ നമുക്ക് ഒരു കോയിലിൽ ഇ എം എഫ് പ്രൊഡ്യൂസ് ചെയ്യാൻ പറ്റുള്ളൂ. So whenever there is a change in magnetic flux, it will produce an EMF in the conductor, and if the conductor is a closed path, then the current will be generated in that due to that EMF. അല്ലെ, ഒരു വോൾട്ടേജ് ഉണ്ട് ആ ഒരു സർക്യൂട്ടിൽ, പക്ഷെ ആ സർക്യൂട്ട് ക്ലോസ്ഡ് പാത്ത് ആണെങ്കിൽ ഡ്യൂ ടു ദാറ്റ് വോൾട്ടേജ് the electrons will move in the closed circuit. That means it will generate current. So that is the electromagnetic induction, the process by which an EMF and hence current is generated or induced in a conductor when there is a change in magnetic flux linking with the conductor is called electromagnetic induction. Okay. Next, we have to study Faraday's law of electromagnetic induction. Some laws in electromagnetism. First one is Faraday's law of electromagnetic induction. Based on this law, some electrical machines are working based on this law. in which first law is whenever the flux linking a coil or current changes, an EMF is induced in it. That means നമ്മളിപ്പോൾ already പറഞ്ഞു when a flux linking with a coil or current changes, an EMF is induced in it. That is the first law of Faraday's law of electromagnetic induction. Then the second law, the magnitude of induced EMF in a coil is directly proportional to the rate of change of flux. And if there are n number of turns, then each flux line will link with this n times. The flux linkage means it is flux into number of turns. I'll explain it. Okay. Okay. We just assume again a coil having number of turns n. ഒരു coil നമ്മൾ എടുക്കുകയാണ്. And the number of turns of that coil is n. Okay. If the number of coils of turns is n, and it will produce some magnetic field lines here, and that due to a magnet there will be lot of electromagnetic field lines are there. So when there is a change in magnetic field due to the movement of magnet or any by giving varying alternating voltage also, it will induce an EMF in this coil. Okay, it may be not clear from this diagram. I will again explain. One magnet is the coil, either it is inside coil is inside or outside, either position. The magnetic field lines linked with whenever the magnetic field lines linked with the coil changes, an EMF is induced in it. That is our first law. And the magnitude of this induced EMF is directly proportional to how much the change in field lines. അതായത് rate of change of flux ന് proportional ആയിരിക്കും produce ചെയ്യുന്ന EMF. അതാണ് second law പറയുന്നത്. Faraday's second law states that the the magnitude of EMF produced in the coil will be directly proportional to rate of change of flux in it. Okay. Then ഇവിടെ കാണാം, ജസ്റ്റ് നോക്കാം. Flux linkages means what is the number of flux linkages means? That is flux into number of turns. How much number of turns into flux is the flux linkage. So the rate of change of flux linkage will give the amount of magnitude of induced EMF. Okay. Then according to Faraday's law of electromagnetic induction, we can write the induced EMF E is proportional to n number of turns n into the flux is phi 2 minus phi 1 divided by 2. Phi 2 means change in flux from the initial flux, that is phi 2 minus phi 1 by time with respect to time, or we can write it as d phi by dt volts. Okay, E into E is equal to d phi by dt volts. That is induced EMF is in differential form. E can be represented as d phi by dt. That is rate of change of flux with respect to time. Okay, E is directly proportional to rate of change of flux. Okay, phi 2 എന്ന് represent ചെയ്യുന്നത് change ചെയ്ത flux. Initial flux is phi 1. So the difference between initial flux and final flux with respect to time is into number of turns will give the induced EMF. Statically induced EMF. Statically induced EMF, when conductor is stationary and magnetic field is moving, then or changing. The EMF induced is called statically induced EMF. Statically induced, there are some terms, നമ്മൾ കുറച്ച് terms already പഠിച്ചതുപോലെ statically induced EMF എന്ന് വെച്ചാൽ എന്താണെന്ന് ഞാൻ just explain ചെയ്യാം. നമ്മൾ already പറഞ്ഞു, when conductor is stationary and magnetic field is changing. Okay, നമ്മളൊരു place ചെയ്തിരിക്കുന്ന കണ്ടക്ടർ, അതായത് ഇവിടെ തന്നെ ഞാനൊന്ന് കാണിച്ചു തരാം. Just we are placing a conductor which is stationary. The coil is stationary, but the magnet magnetic field produced by that magnet moving either direction, either left or right, then it will change the magnetic flux linkages with this coil. So this process will produce an induced EMF. Coil is stationary, magnet is moving, that is magnetic field is moving. Then also it produces an induced EMF. The induced EMF is known as statically induced EMF. Okay. Then self-induced EMF. Self-induced EMF means in a coil due to change of its own flux linkages with it is called self-induced EMF. Okay. Or a coil. When current flowing through it changes, when a current flowing through a coil will changes, alternating current is given to a coil, it will produce a change in magnetic field. ഒരു കോയിലൂടെ കറണ്ട് ഫ്ലോ ചെയ്ത് കഴിഞ്ഞാൽ it will produce a magnetic field. So self-induced EMF means the induced EMF in the coil due to change of its own flux linked with it. ഒരു കോയിലിനകത്ത് ഓൾറെഡി ലിങ്ക് ചെയ്തിരിക്കുന്ന ഫ്ലക്സിലുള്ള ഇറ്റ്സ് ഓൺ ഫ്ലക്സ് ലിങ്കേജിലുള്ള ചേഞ്ചസ് കാരണം ഒരു ഓൾട്ടർനേറ്റിംഗ് കറണ്ട് ആണ് ഇപ്പോൾ ഒരു കോയിലിൽ കൊടുക്കുന്നതെങ്കിൽ ഇറ്റ് വിൽ പ്രൊഡ്യൂസ് ആൻ ഓൾട്ടർനേറ്റിംഗ് ചേഞ്ചിങ് മാഗ്നറ്റിക് ഫീൽഡ്. അത് കാരണം അതിനകത്തൊരു ഇൻഡ്യൂസ് ചെയ്യും. വെനെവർ ദർ ഇസ് എ ചേഞ്ച് ഇൻ മാഗ്നറ്റിക് ഫീൽഡ് ഇൻ എ കോയിൽ ഇറ്റ് ഇൻഡ്യൂസ് ആൻ ഇ എം എഫ്. സോ ആ ഒരു ഇ എം എഫിനെയാണ് നമ്മൾ സെൽഫ് ഇൻഡ്യൂസ്ഡ് ഇ എം എഫ് എന്ന് പറയുന്നത്. ആ സെയിം കോയിലിലുള്ള മാഗ്നറ്റിക് ഫീൽഡിലുള്ള ചേഞ്ചസ് കാരണം പ്രൊഡ്യൂസ് ചെയ്യുന്ന ഒരു ഇ എം എഫിനെയാണ് സെൽഫ് ഇൻഡ്യൂസ്ഡ് ഇ എം എഫ് എന്ന് പറയുന്നത്. Then magnitude of that self-induced EMF is self-induced EMF in the coil is proportional to rate of change of current in that coil. നമ്മൾ ഒരു കോയിലിൽ സെൽഫായിട്ട് ഇ എം എഫ് പ്രൊഡ്യൂസ് ചെയ്യാൻ കഴിയപ്പോഴാണ് അതിനകത്തൂടെ ഫ്ലോ ചെയ്യുന്ന കറണ്ട് ചേഞ്ച് ചെയ്യുമ്പോൾ മാത്രമാണ്. അതായത് ഒരു കോയിലിലൂടെ കറണ്ട് ഫ്ലോ ചെയ്യുന്നത് ആ ഓൾട്ടർനേറ്റിംഗ് കറണ്ട് ഒരു വേരിയിങ് കറണ്ട് ആണ് നമ്മൾ കൊടുക്കുന്നതെങ്കിൽ മാത്രമേ പ്രൊഡ്യൂസ് ചെയ്യുന്ന മാഗ്നറ്റിക് ഫീൽഡ് വേരി ചെയ്യുള്ളൂ. സോ വെൻ എ varying current is flowing through a coil, it will produce an alternating magnetic field in it, and that alternating magnetic field will produce an EMF in the coil. So the change in magnetic field in its own coil will produce an EMF that is called self-induced EMF. Okay. Then magnitude of self-induced EMF is proportional to rate of change of current. Okay. Then what will be the unit of self-inductance? This ഇങ്ങനെ പ്രൊഡ്യൂസ് ചെയ്യുന്ന ഇ എം എഫിന്റെ യൂണിറ്റ് എന്ന് പറയുന്നത് ഇറ്റ് ഇസ് ഹെൻറി. നമുക്കറിയാം ഇൻഡക്ടൻസിന്റെ യൂണിറ്റ് ഹെൻറി ആണ്, കപ്പാസിറ്റൻസ് ആണെങ്കിൽ ഫാരഡ്. ഓക്കെ, അപ്പൊ സെൽഫ് ഇൻഡക്ടൻസിന്റെ യൂണിറ്റും ഹെൻറി ആണ്. സോ വി ക്യാൻ റെപ്രസെന്റ് ഇ ഈസ് ഈക്വൽ ടു എൽ ഇൻറ്റു ഡി ഐ ബൈ ഡി ടി. ഓക്കെ, E is equal to L into di by dt. You can see L into di by dt. അതായത് self-induced EMF in a coil is proportional to rate of change of current, and that proportionality will be equated to an inductance produced in that coil. So E is equal to L into di by dt എന്നാണ് നമ്മൾ represent ചെയ്യുക. Okay. Then next is effect of inductance of a coil or circuit. Just ഓരോ എഫക്റ്റ് ഇതൊക്കെ നിങ്ങൾ വായിച്ചു നോക്കാം. When the current in a coil or circuit changes, inductance opposes this change. നമ്മളൊരു കോയിൽ റെസിസ്റ്റൻസ് പ്രോപ്പർട്ടി പറയും. What is resistance? Resistance when in a conductor the property to oppose the change in current will be known as, which is known as resistance. എന്ന് പറഞ്ഞ പോലെ ഒരു കോയിലിലുള്ള കോയിലിന്റെ പ്രോപ്പർട്ടിയാണ് ഇൻഡക്ടൻസ് എന്ന് പറയുന്നത്. When the current in a coil or circuit changes, inductance will oppose this change. When the current in the coil is steady, there is no induced EMF and hence no opposition due to inductance of the coil. അതായത് കറണ്ട് കോൺസ്റ്റന്റ് ആണെങ്കിൽ there will not be no induced EMF. ഒരു കോൺസ്റ്റന്റ് കറണ്ട് ആണ് ഒരു കോയിലൂടെ ഫ്ലോ ചെയ്യുന്നതെങ്കിൽ it cannot produce an EMF because there is no change in magnetic flux. According to Faraday's law, you know that whenever there is a change in magnetic field, then only it will produce an EMF. So here അങ്ങനെ ഒരു മാഗ്നറ്റിക് ഫീൽഡിന്റെ ചേഞ്ച് വരുന്നില്ല, അതായത് കോൺസ്റ്റന്റ് കറണ്ട് ആണ്. സോ ഇറ്റ് വിൽ പ്രൊഡ്യൂസ് ഓൺലി എ കോൺസ്റ്റന്റ് മാഗ്നറ്റിക് ഫീൽഡ്. Constant magnetic field cannot produce an induced EMF. So when there will be no induced EMF in it. And inductance occurs only when the current in the coil or circuit changes. അതായത് ഒരു കോയിലിലെ കറണ്ട് ചേഞ്ച് ചെയ്യുമ്പോൾ മാത്രമാണ് അതിനകത്ത് ഇൻഡക്ടൻസ് എന്ന് പറയുന്ന ഒരു പ്രോപ്പർട്ടി ഒപ്പോസ് ചെയ്യുന്നത്. When the inductance means it is the opposing property which opposes the change in magnetic field. Okay. Then what are the factors upon which inductance, which depends on L will depend upon number of turns of the coil and also length of coil and cross-sectional area of coil and also core permeability. So inductance will depends on number of turns of coil, length of coil, cross-sectional area of coil, and also core permeability. Inductance means its property of a conductor or a coil. So it will depends on the main constructional feature that a coil have, how much length it have, or how much the cross-sectional area and the permeability of that material, and how much number of turns is there. അതിനൊക്കെയാണ് ഇൻഡക്ടൻസ് ഡിപ്പെൻഡ് ചെയ്യുന്നത്. Inductance is which is represented by letter L. Okay, L എന്ന് പറയുന്നത് കൊണ്ടാണ് നമ്മൾ represent ചെയ്യുന്നത്. So we have studied self-induced EMF. Next term is mutually induced EMF. Mutually induced EMF means it is mutually induced EMF is the EMF induced in a coil due to the changing current in another neighboring coil, which is called mutually induced EMF. I will explain it with a diagram. Just assume there are two coils. One coil which is placed near to another coil. Okay. That means, but it is not physically contact with both the coil. Okay. രണ്ട് കോയിൽസ് തൊട്ടടുത്തടുത്ത് പ്ലേസ് ചെയ്യുക, but they are not physically contact with each other. Okay. So when we apply an alternating current on first coil, the first coil, the second coil. Okay. First coil നമ്മൾ ഒരു alternating current apply ചെയ്തു. When we apply an alternating current, what happened when a changing current flowing through a magnet coil, when an alternating current is applied to a coil, it will produce a magnetic field. Whenever a current flowing through a coil, it will produce a magnetic field. So first coil നമ്മൾ കൊടുത്ത current കാരണം ഇവിടെ ഒരു magnetic field produce ചെയ്തു. That magnetic field will linked with the second coil because it is placed near to the first coil. So this alternating current will produce an alternating magnetic field, a self-induced EMF in the first coil, and the self-induced because it produces self-induced EMF in this coil because we are giving alternating current. Just ഒന്നുകൂടെ ഞാൻ explain ചെയ്യാം. What is mutually induced EMF? Okay. We are assuming there are two coils. First one coil, in first coil we are applying an alternating current. When a current flowing through a coil, it will produce a magnetic field. Or magnetic field produce ചെയ്തു. And it will induce an EMF in the first coil. Okay. That magnetic field, that induced EMF is known as self-induced EMF. അതായത് ഫസ്റ്റ് കോയിലിൽ അതിലുള്ള ചേഞ്ച് ഇൻ മാഗ്നറ്റിക് ഫീൽഡ് കാരണം സെയിം ഫസ്റ്റ് കോയിലിൽ പ്രൊഡ്യൂസ് ചെയ്ത ഇ എം എഫിനെയാണ് സെൽഫ് ഇൻഡ്യൂസ്ഡ് ഇ എം എഫ് എന്ന് പറയാം. വെൻ ദിസ് കോയിൽ ഇസ് പ്ലേസ്ഡ് നിയർ ടു ദ സെക്കൻഡ് കോയിൽ, ദ ഫ്ലക്സ് lines of the first coil will linked with the second coil also. So this alternating field will produce another EMF in the second coil. Here also an EMF will be produced. An EMF was produced here. That EMF or voltage is known as mutually induced EMF. So the EMF induced in a coil due to the changing current in another neighboring coil is called mutually induced EMF. അതായത് ഫസ്റ്റ് കോയിലിൽ പ്രൊഡ്യൂസ് ചെയ്യുന്ന ഫസ്റ്റ് കോയിൽ ഒന്നുകൂടെ ഞാൻ എക്സ്പ്ലെയിൻ ചെയ്യാം. ഫസ്റ്റ് കോയിലിൽ നമ്മളൊരു കറണ്ട് കൊടുത്തു I, and it will produce a magnetic field in this coil, and a nearby coil placed near to the first coil will be also linked with this varying magnetic field. So the varying magnetic field produced in first coil will produce an EMF in the second coil. That EMF is known as what? Mutually induced EMF. Okay. Magnitude of induced EMF is, mutually induced EMF in a coil is B into rate of change of current. That is magnetic flux density into rate of change of current in coil A. That is mutually induced EMF in a coil B into rate of change of current. So that is EMF is equal to mu into di by dt. This M is the mutual inductance. M into di by dt. That is the magnitude of induced EMF in the second coil. Mutually induced EMF in coil B into rate of change of current in coil A. Or coil first coil rate of change of current in and also mutually induced EMF in second coil. Okay. അതിന്റെ പ്രോഡക്റ്റ് ആണ് മാഗ്നിറ്റ്യൂഡ് ഓഫ് ഇ എം എഫ് എന്ന് പറയുന്നത്. Then expression of mutually induced EMF is EM is equal to M into di by dt. Mutual inductance M into rate of change of current in first coil. Okay. Next, ഇതൊക്കെ നിങ്ങൾ just വായിച്ചു നോക്കാം. What is magnetic circuit reluctance? All other terms I have explained in the last class itself. And also and comparison of electric and magnetic circuits I have given yesterday before 2 days before. I have given already the comparison between electric and magnetic. Just read this. Okay, thank you.